the Sustainable Activities Centre for donating the booking of this room. It really wasn't something that we expected, but they felt the subject was so important that it was right down the line of what they support. So we really appreciate that. Thank you, Sharon. So yeah, to introduce Don, as some heard this morning, Professor Don Huber is from the Purdue University in the USA, and he's worked around plant pathology for at least 55 years, so it's quite amazing. He is now retired, but has clearly not stopped working. He's working probably harder than ever.
I'm not dead yet.
And I did ask him for a bio that I was nervous as to whether I could pronounce even all the things that he's done, let alone understand. But he said it was 60 pages long, so we're going to prevent you from needing to hear 60 pages. So, and the other thing that I thought was really significant was finding out that you've been working with and understanding the formula for glyphosate since 1974. Which is the year I was born. So, yes, so it's a double up for some people, but I want to say again for those that didn't hear this morning, how privileged we are to have Don here today, this morning and this evening. The past 2 days at NutriSoil, on the Briggs property out at Rutherglen yesterday, where he really came to life. It was really great to be out in the paddock with Don. Phone meetings with West Australian customers, with the Haggertys, and speaking on ABC radio. Did anybody hear Don on the radio yesterday morning? He was interviewed as a follow-up after the Monsanto papers, and it was just an amazing coincidence for him to be here at the time when that was showing. And so, yeah, we got to sit down and watch it with him. So yes, we've learnt so much from Don, and he's just so extremely knowledgeable. And he's touching on the GMOs, but not so much detail as this morning, the genetically modified crops, because they're fairly strongly linked with the rapid increase in glyphosate usage. And the way chemicals work has been really significant for us at NutriSoil. So we have a biological fertiliser, and we're also working. Most of our customers aren't organic, so the farmers are using chemicals in their system as well. It's really important for us to understand how they interact in the farming system, because we know it's not all about products; it's about whole farming systems. And for us to learn that glyphosate, how it affects the minerals in causing limiting factors in their future crops, is really significant for us to be able to pass on to other farmers. So I don't want to take any more of the time that Don needs to speak tonight, but I will say that we'll have a presentation for most of the time, for about an hour or so, but we'd really like to have opportunity for questions and discussion. And what's really special this evening compared to this morning is that we've got the farmers and the consumers in the room. So no question's a silly question. I think there's a lot of ignorance around this subject, and we don't usually all have someone with the knowledge of Don in the room to help answer it, and the farmers also to, if there's any questions that the, I say consumers, we're all consumers, the non-farmers, if they have about, just myths and ideas that they've heard about chemical usage on the food that they're eating. All right, I'll pass over to you, Don.
Do I need the microphone?
Yes. Yeah.
Well, thanks, Rochelle. I appreciate the opportunity and the hospitality that's been extended. It's always great to come to Australia. Great people and a fun trip. So thank you for all of you. The mural that you see here is on the side of a cafe in Los Angeles, and it depicts the concerns that many people have as far as the GMO crops and the chemicals that they're engineered to tolerate, that we see accumulating in our food and our feed products, and that. The cafe serves only organic foods, and so it has a fairly large clientele that go there, but they're not afraid to advertise what their concerns are and why they're trying to be a beacon in on the horizon there. Had a woman that had lost her husband in 50 years, and she was alone, and her children were fairly concerned that she might get a little depressed. She didn't have a lot of hobbies, a lot of things to do, and so one of them suggested to her that she get a pet, something to take her time and give her something to kind of share that time with. And so she went over to the pet store and explained her situation to the pet store owner, and the pet store owner grabbed her by the arm and took her to the back of the pet store and showed her this beautiful Brazilian parrot and said, this guy will take care of your needs, your problem there. He said he'll talk your leg off, be a good companion, give you something that you have to feed every day and take care of, and kind of fill that void that she had. So that she bought the parrot and took it home and came back the next day to the pet store and said, well, he hadn't said anything to me. What do I have to do to get him to talk? The pet store owner said, oh, parrots like to move around a little bit and need the exercise. Said, you have some stairs. Well, she bought the stairs, put them in the cage, came back the next day and said he still hadn't said anything to me. What do I need to do? And the pet store owner said, oh, parrots have a real high vanity quotient. Said, you have a mirror. And so she bought the mirror and put it in the cage. Came back the next day and said he still hadn't said anything. Said, what do I need to do to get him to talk to me? Said, oh, do you have a swing? So she bought the swing, put it in the cage, and came back the fourth day with a dead parrot here and said, you know, you hardly said anything, you just keeled over dead. Said, what's the problem? And the pet store owner said, well, you've had him for 4 days essentially. Said, what did he say to you when he keeled over? Said, well, I wasn't sure. It's kind of garbled a little bit, but it was something like, doesn't that store sell any food? Well, it's easy for us to get distracted with all the marketing, and we kind of lose track of what our real importance is in agriculture as the basic infrastructure of our entire society. What you do in agriculture is going to determine everything else that society is able to do. That production efficiency of a nutritious food, economically available, is going to be very critical for any society. We forget that we have an ecology that we manage when we're farming. We tend to look at our problems and we say, okay, I need a Stinger missile or I need a silver bullet to solve these problems. And there are commercial enterprises that say, I've got the silver bullet for you. And so we've focused on that with chemical agriculture. We've been farming primarily with silver bullets rather than remembering that in farming and agriculture, it's really managing an ecology. And the consequences then of that silver bullet approach is that we have sick soils, vanishing ecological support, deteriorating crop and animal health, and increased human suffering. Because we're not managing that ecology, we're just chasing our tails as we look for a new silver bullet every time we get a resistant weed or every time we have another problem or a new disease outbreak, so that we keep dumping more problems into the system rather than solving the problem by managing this ecology. One of the very serious challenges that we have now is with a very simple compound that we call glyphosate, initially marketed as Roundup. A very simple compound of just the simplest amino acid. You see on the end over there, glycine, attached to a PO3. Well, we use PO4 all the time, phosphate, in agriculture, and we need it in our food. It's a very essential mineral for us, both for energy transfer and a number of products that it's a constituent of. When you put that PO3 on it, on that simple amino acid, it changes its characteristics dramatically. Very different from if we had a PO4, it would be very different. With the PO3, it's a synthetic amino acid, has some other characteristics that I'll show you, but also in every bottle of Roundup, you have a byproduct of the manufacturing process called nitrosamines. Nitrosoglyphosate, free nitrosamines are the tobacco carcinogen. It's in every jug of glyphosate that you purchase, you're going to have a tobacco carcinogen and 4 or 5 different forms of it, because you can't remove it from the manufacturing process, and even if you did, it's synthesized as a nitrosoglyphosate in the body. Nobody talks about it. Very potent carcinogen. Has some other characteristics. So you not only have the characteristics of the glyphosate itself, but you also have a very toxic carcinogen as a byproduct in that, that's a contaminant in your material. Well, we use just a little bit of it. Most heavily used chemical in agriculture worldwide that we've ever had. This 225 million pounds a year in the U.S. is 2 years before Roundup Ready alfalfa. We're now up to about 300 million pounds that are used every year in agriculture. We have another 250 to 300 million pounds that's used in forestry, highway right-of-way, utility ways, home gardens, for your concrete driveway or other areas. So it's about half, a little over half for agriculture and about half for other things in the environment of this very unique chemical that's been considered 100 years before a chemical will be invented that has comparable characteristics to glyphosate. It's very simple but very unique chemistry, very unique chemical. It was first patented in it was invented in 1957. It was patented by Jim Chang, Stauffer Chemical Company, in 1964 as a mineral chelator. It was used to clean steam pipes and boilers. Does a great job. It has a broad spectrum chelation potential for any positively charged elements. So calcium, magnesium, and iron in those boilers, you could descale it. Those are also elements that we need in our body for mineral nutrition, along with magnesium, or along with iron and copper and zinc and cobalt and molybdenum and a number of any of those positively charged elements, potassium, are all chelated, immobilized by glyphosate. We use chelators positively in agriculture and in medicine to increase the solubility or the availability of nutrients and other materials. Chelation merely means that you have a chemical that will grab onto another element without being chemically incorporated and change its physical characteristics. With glyphosate, it's a mobilization. It's not a matter of increasing solubility and movement over the cell membrane like you'd have with EDTA or with citric acid or some of the amino acids, some of those materials, DTPA, that are used as chelators. With glyphosate, my research, once it's chelated in the plant to that mineral's not available as long as it's in the plant. It immobilizes it. That's how it works. Manganese is a required cofactor for the EPSPS, or the FMN reductase is the cofactor for the actual EPSPS. Glyphosate chelates out the manganese, shuts down the FMN reductase enzyme, and shuts down the Sugarcane pathway then. Directly also chelates with cobalt, which is the cofactor for the arabinolacetohepulose enzyme, which is one step just above the EPSPS enzyme. So you have a series of enzymes that are actually shut down, downregulated with glyphosate in that shikimic acid pathway that functions as an herbicide. So it was patented 10 years after it was patented as a chelator. Monsanto patented it as an herbicide. Broad spectrum herbicide kills everything because it's such a broad spectrum chelator to shut down 291 enzyme systems. In 2000, they patented glyphosate as a broad spectrum antibiotic. It's a very powerful antibiotic, but it's an antibiotic against the beneficial organisms that we rely on in our gut and in our environment to make minerals available for producing those aromatic amino acids for brain function and our immune system and a number of other systems there. But it stimulates the pathogens. That's why it's such a good herbicide also, is that it kills off the beneficial organisms that would normally suppress fusarium and phytophthora and rhizoctonia, and all of our pathogens are all very sensitive to glyphosate, so that the pathogens then fill that void in nature that would otherwise be occupied by beneficial organisms. It's a synthetic amino acid, so that Dr. Anthony Samsel's research is showing now that glyphosate itself, as a glycine phosphonate, can actually incorporate in the proteins in place of the glycine amino acid. Well, glycine occupies about 50% of our proteins for many of the enzyme systems that we rely on. When glyphosate is incorporated by mistake, you have a folding of the protein because you also have the phosphonate group on that, so that you have a malfunctioning protein for many of those enzymes. Again, it's a very unique chemistry. It can be very persistent in the environment, also in our bodies. It's a bioaccumulating chemical that accumulates in the brain, bones, bone marrow, and all of our organs, especially liver and kidney and heart, pancreas, so that the very extensive involvement then in our physiology and our functioning and our animals' functioning, as well as what happens in the soil and in the plant, can be very persistent because as a synthetic amino acid hasn't had a lot of exposure to develop organisms that will degrade it. In a good agricultural soil, like you have in your silt loams, silty clay loams here in Australia, its half-life is about 20 years, 20 to 22 years. May be detoxified by chelation with the minerals as an herbicide, but it's still present, and it can be then desorbed from those chelated conditions when you apply your phosphate fertilizer. So that you release it then, and I've met with a group of farmers in Canada, Saskatchewan area, 18,000 acres, where they couldn't get a single crop off of it because they desorbed the glyphosate that had been accumulating for 15 or 20 years, and their wheat and barley got about this high before it died. Peas hardly, and lentils hardly even made it out of the ground. Very persistent chemical, degrades a little quicker in sandy soils than it does in the clay loams and silt loam soils there. Again, when it chelates with those nutrients, they're not available then physiologically, and the nutrients serve a function for us as components of various constituents in our bodies, and our animals' bodies, and in the plant, so that it can serve in those areas, and we see a breakdown then of a lot of our tissues, a lot of our materials. If you have chelation of zinc and boron are very critical for membrane permeability. All of a sudden, in a zinc deficiency, the plant cells or human cells start leaking amino acids, sugars, and phenolic compounds. In a plant, those go out into the root system so that it stimulates the pathogens then to create a more severe disease pressure for us. And that's why our fungicide rates have had to skyrocket, along with the increase in glyphosate with a lot of our genetically engineered plants. But the minerals are also, again, those regulators and activators, inhibitors of our physiological processes, because they serve as the cofactors for the enzymes. I've likened it here to having 200 or 300 horsepower engine in your tractor or even in your pickup. In fact, a few cars have 200 horsepower now. You have that in your car, can do a lot of work. You can get up from 0 to 60 in a hurry. You got 200 horsepower to respond to that throttle. Doesn't do anything until you turn the key on. The key to those enzyme systems is the mineral. So you have the enzyme there. It's not able to do anything if you immobilize the cofactor, that mineral. All of our herbicides are chelators. That's how they work. They immobilize, or they serve as that key to turn off the engine. And every one of them chelate. Most of them fairly specifically for copper or for zinc or for iron or for manganese. Magnesium. Magnesium is a cofactor for 800 enzymes. Manganese for about 28. You'll see all of those that are involved. When you chelate the mineral, you shut down that particular enzyme. So in developing the herbicides, and I've been involved in developing some of those with Tordon, with some other nitrification inhibitors, nitropyrin, and several that we look for a chelator that will tie up specific minerals that are critical for pathways. So we say, well, we have the ALS inhibitors, the photosynthetic inhibitors. The other thing is we don't say, well, it's a magnesium inhibitor, it's a manganese inhibitor, or chelator. We go by the pathway usually when it's listed there. But all of our herbicides and many of our other pesticides are chelators. And so if you look at those minerals and their chelation, that minerals that they chelate are the herbicides, and the minerals that they chelate, and this is just a partial list, but you can see the critical need and critical availability of those minerals. We say, well, the micronutrients, we don't need very many of them. That's because it's serving as a key rather than as the enzyme, rather than the motor there. But you can go through and look at all of them, and all of our herbicides are chelators. And you can then look at the different pathways. This is the shikimic acid pathway. You can see up at the top here, you have the EPSPS, and you have the arabinocetohepulose 7-phosphatase. Up there, one where glyphosate chelates the cobalt, and the other one where it chelates the manganese, where it's involved. But you'll see all the way through there, copper, you'll see all of the other positively charged cations. It's chelating the whole system. It's not just shutting down the EPS or the arabinocetohepulose enzymes. But just as an example, you can, connect all of the dots then with the various physiological symptoms and those particular minerals that are serving as the cofactors for the enzymes. You see glyphosate up here, but you could put glyphosate anywhere you have manganese or iron or cobalt or copper, anywhere in there, and glyphosate's going to stop that particular pathway, independent of what it's stopping anywhere else in the system. Now, if you shut it down up the top of the pathway, everything below it, kind of that domino effect loses. Very powerful chelator, very dynamic effect on mineral uptake at extremely low rates. At a 40th of the herbicidal rate, it will reduce the uptake of iron by 50%, manganese by 80%, and then the translocation in the plant, you've inhibited the translocation of all three of those essential minerals by 90 to 95%. That's with 11 grams per acre, about a ½ ounce per acre, or about 12 parts per million. But you have a very dynamic effect then or parts per billion, not parts per million. 12 parts per billion, you have very dramatic effect in inhibiting the translocation of those minerals for use in the plant. So you can see that it's a very powerful chelator, very powerful impact then on nutrition. We used to advise our farmers to, when they look at that range of nutrients that you'll find in all the textbooks and handbooks on mineral sufficiency levels, used to say, well, shoot for the middle somewhere in your environment and program, unless we could identify pH effects or waterlogging or drought effects or whatnot that they may need to modify from that middle of the road, and you're probably in the ballpark in good shape for the variations that we see in ag. With glyphosate, we tell them shoot for the top, or at least 3/4 way up of that range that's given for all the minerals, because it has such an effect directly as a chelator, but also as an antibiotic against the organisms that are going to work in the soil for you if you have a healthy soil. And so we changed a lot of our recommendations. You can look at this. This is even with the Roundup Ready soybeans, because there's nothing in the Roundup Ready plant that does anything to the glyphosate. It's still moving around as a systemic water-soluble compound. Moving around the plant is a very strong chelator. All the genetic engineering does is let us dump it on the plant without killing it. As an alternative EPSPS pathway, but you can look here and you see, in your young leaves, you've got a 40% reduction in calcium. That's your binding calcium and magnesium for structural strength in your cell walls. Magnesium for photosynthesis. Look at your manganese, 29% in your mature leaves, which are your real workhorse in that system. And you see a further reduction, 48%, only about half of the manganese required. If you don't have manganese, you're not going to have enough hydrogen to combine with the carbon dioxide, because you can't split the water. You have to have the manganese to split the water to give you the hydrogen for combining with CO2 to form that sugar. We get the oxygen then. So that our whole objective in growing that plant is to capture the sun's energy through that process of photosynthesis. Magnesium is required for the chlorophyll molecule to capture the sun's energy to drive that process. And so you start compromising in those areas from a crop production and production efficiency standpoint. You see the compromise, but then look at what's left in the grain that we're harvesting and we're going to eat or we're going to feed to our animals. We have a lot of empty calories. We're not producing that quality, nutritional quality that we need for our own health and well-being. Glyphosate's been a powerful tool for us in agriculture for weed control because it's a very broad spectrum chelator, but it's also a systemic chemical. You can just squirt it on the plant and it distributes throughout. You don't have to have a high volume to make sure you get good coverage of the plant as a contact herbicide or that, because it distributes itself in the plant. It accumulates in the root tip, shoot tip, and reproductive structure. If you're putting it out as a harvest aid or a desiccant before harvest, usually goes out 2 or 3 weeks before harvest to dry it down. The only place that glyphosate can go then, physiologically, is right in the seed. And you'll see that glyphosate will move in the seed in corn, even through the black layer formation that we normally say, well, everything's gone. Glyphosate will still move in. If you apply glyphosate at that late stage, same thing in wheat and barley and oats. So that we accumulate then the glyphosate in those tissues that we're using for feed and food and that even as fiber, we see that it can be desorbed or absorbed through the skin from bedding. I'll get on that a little bit. As it moves through the plant then, you see that as it moves down into the root system, it shuts down the Sugarcane pathway, which is the primary defense mechanism of the plant against those soil-borne pathogens. Shuts it down, so it gives the plant a bad case of AIDS. 18 to 20% of it will move then out of the root into the root exudates, into the soil, so that it then has the antibiotic effect to compromise the normal biological controls that would suppress many of those diseases. It stimulates the pathogens because they're resistant to the glyphosate, so that it stimulates, again, your fusarium and rhizog, Pythium, Phytophthora, and many other pathogens, as it's there to increase your soil-borne diseases. And it's that mechanism, it's those organisms that actually do the herbicide mode of action. That's why it takes 4 or 5 days or a week before the plant finally succumbs. It gives it a bad case of AIDS. You get very rapid colonization and movement in, but it's a disease process that actually kills the weed to give it the effectiveness there. Again, it reduces nutrient uptake. All of these beneficial organisms that we have, your mycorrhizae, your iron and manganese reducers, your sulfate oxidizers, sulfur oxidizers, all of those that make those minerals available for plant uptake, very sensitive to glyphosate. So you wipe them out of the environment. We change that entire ecology that farming used to manage. It's no longer the same system. We've biased the biology very dramatically in that whole process. Some research we did on with some consulting in Central America. We were developing, trying to get glyphosate out of the sugarcane ripening program because of so many of the workers are developing end-stage kidney failure. 1 out of 4 will be dead this year in El Salvador from end-stage kidney failure from glyphosate exposure during sugarcane harvest. And so we wanted to move that out. To get the glyphosate out, we had to have an alternative for ripening. We developed a nutrient source for that. We go in with some boron, with some molybdenum, and some manganese. We want to increase sugar production. We don't want to stop it 4 weeks before harvest. That's a prime time for sugar production. They use glyphosate because it shuts down tiller growth, and then you have that energy. But it sacrifices then your next crop through the ratoon crop. So we wanted to avoid that, but we still needed to push the physiology towards the senescence or towards the storage capacity. And we did it with boron to move the sugars on into that storage capacity, with manganese to keep producing the sugar, to use up the resources that the plant had already established for sugar production, and the molybdenum so that we could utilize that stored nitrate nitrogen that was typically interfering with sugar extraction. We can get up to 2 tons more refined sugar for $16 more with that system than the glyphosate, and avoid all the problems and the replanting that's required when you use the glyphosate for your next impact on your next crop. But you can see that within 6 hours, after applying the glyphosate to that 12-foot high sugarcane plant, that you have more than 100 times the glyphosate systemically moved in that tissue, more than 100 times than it would be required to chelate all of the unbound cations in that stalk. And then it continues on up for a couple of days before it starts dropping off from root exudation and just binding, primarily binding. 80% of the glyphosate is going to stay in the plant or the product as long as the product exists, until it's fully decomposed. But you can see then what happens to your manganese and iron, or they bottom out in that 6-hour period, just like you see the distribution. Not quite as severe, about a 30% reduction in your zinc. Well, this is a prime time when we want to keep that machinery really working for us rather than shutting it down in the death row like we have with the glyphosate. And it's been a very successful program for us to eliminate the need for glyphosate to start with, and the damage that we get, and especially the health consequences that I'll mention a little later. You can see it's a very strong chelator. Now we recognize that there are a lot of environmental conditions that influence nutrient uptake, pH being one of them. In Wisconsin, on the high pH soils, have lime-induced chlorosis, as we refer to it, so that they developed a simple $2 seed treatment with reduced iron and ferrous sulfate that took them from 23 bushel up to 56 bushel. You started meeting that need of iron. When they put the glyphosate out on these Roundup Ready soybeans, though, went from 23 bushel down to 8 bushel because of the chelation of those essential minerals. When they added the seed treatment, it only brought them up to 19 bushel rather than the 23 bushel that their non-treated, non-glyphosate treated plants were yielding. My research indicated that if they would have also put manganese along with the iron, that have probably had 56 or maybe 65 bushel, because you have a lot of hidden hunger with the micronutrients that we don't observe don't see a visual symptom for it, but physiologically you see the compromise in that activity. Even in the Roundup Ready soybeans, you see a very dramatic impact physiologically on them. Again, there's nothing in that genetic engineering that does anything to the glyphosate that's applied. So you still compromise. You have the shikimic acid pathway compromised because the genetically engineered plant isn't nearly as efficient. So there's a little reduced lignin production. You see nutrient values dropping in that soybean. You see it also in the Roundup Ready alfalfa. Not nearly as nutrient dense. You see reduced photosynthesis because those minerals aren't as efficiently functioning nutritionally as they would be in the non-GMO isolate there. But the other thing that's interesting is that it takes twice as much water to grow a pound of dry matter in the Roundup Ready plant treated with glyphosate than it does the non-Roundup Ready isogenic line. Oh, what do you have in agriculture that you can count on at least sometime during the season? Usually is an extended period where you may go an extra week or 2 weeks, or in some situations like you're seeing here, maybe a year that's only half the moisture for you. And again, it takes twice as much water because of that reduced efficiency to produce a pound of dry matter in a Roundup Ready treated with glyphosate than its isogenic line without that. You say, well, is that really a critical factor for us? In 2012, we had a pretty good drought. We went a couple extra weeks without rain in the Midwest. These are non-GMO and GMO soybeans hit with the glyphosate. They missed the spraying the second time, so each time they put a little more glyphosate out, it just intensified that drought susceptibility. Makes a big difference. I didn't put the corn one in here, 100 bushel difference in corn with plants that are separated only by, they're planted the same day, same soil type, same weather. The only difference was the glyphosate and their separation by a 60-foot gravel road. But what you'll see then, this is winter wheat, some research of wheat in the group at Stuttgart. And our label says it's perfectly all right to spray glyphosate anytime before plant emergence. The Israeli label says it's not safe to plant for up to 3 weeks after you've sprayed your glyphosate because it takes time for it to be chelated and detoxified as an herbicide. So that if you plant it 2 days after your glyphosate burned down, you can see that there's a lot of struggling plants. They may finally get a stand, but it's not the vigor that you used to have, not the nutrient activity. If you wait for 14 days, as they showed, in Israel, up to 3 weeks, 21 days, then that glyphosate will be detoxified somewhat so that you get a much better stand and much better vigor. And if you look at those plants, ask an agronomist, well, what's happening and why is it struggling to get out of the soil and get established? And they'll look at it and they'll say, well, too cold a soil, too wet a soil, too much residue on the surface. We know those things will all reduce nutrient availability. They don't connect the glyphosate and its chelating ability and antibiotic activity with these symptoms. But you look at the symptoms and it tells you right off that just really struggling for those nutrients. You can see the tip die back, the chlorosis, typical textbook symptom of copper deficiency. Yeah, it's also a symptom of drought. When you have a drought, you don't have solubility of nutrients and uptake. Okay, I've got to get moving here. But you can see all of those symptoms. Again, glyphosate can be desorbed from that detoxified state and become an active compound then 10 or 15 years after you have been applying it and haven't seen any problems. All of a sudden it can be desorbed when you put out your phosphate fertilizer and become an active herbicide again. As you see here, look at the reduction in uptake and availability of those nutrients in the plant compared to what you'd have if you didn't have the desorption there. So a lot of our farmers say, well, the crop just doesn't look as good, it's not as vigorous as it used to, and they'll blame the seed. Maybe partly the seed because it has fewer nutrients that are involved in that early seedling vigor. But if you look at that difference, what you're seeing is that chelation and antibiotic activity of the glyphosate that changes nutrient availability, and also probably seeing some desorption of those nutrients in that area. It's a field in Georgia of pumpkins planted perpendicular to the previous year's Roundup Ready corn. And what you look there with the yellow is where that glyphosate had moved out through the root exudates into the soil. Still there, tying up the iron and the manganese and magnesium. And you can see the damage then to the pumpkins the year after that from the residual effects of the glyphosate. Again, it's a very powerful antibiotic, but for the beneficial organisms, but it's a stimulus to the pathogens. So this Dr. Robert Kremer's and Zobioli's research here at the University of Missouri, 500% increase in fusarium colonization of the Roundup Ready soybeans compared to the normal soybeans there, the non-genetically engineered. Again, mentioned you can't kill a plant with glyphosate in sterile soil. You stunt it, shutting down 201 enzymes actually, but none of them in a primary cycle or secondary cycle, so that in 2 weeks in sterile soil, that plant recovers those nutrients that have been chelated and immobilized. It can start growth again, and all of the buds will break, and you'll see a very strong bushy plant that will emerge from that. And field soil, where you have all your soil-borne pathogens, it's the death knell for them because the system's compromised for recovery. So as a consequence, we have over 40 diseases now that on our threat pathogens committee we refer to as re-emerging diseases. At one time we had very excellent control of these diseases. Those controls aren't working very well now because many of them relied on those nutrient cycles and the biological suppression that we had. We have some new diseases. This corn ospiter root rot on soybeans. You can see over on the far right there, that increased disease when you put a little glyphosate on the foliage of the Roundup Ready soybeans. Stimulates that organism. It becomes a very intense pathogen there on it. We can see it with a lot of other diseases. This is another disease that didn't exist before 1996 with the genetically engineered plants, tolerant of glyphosate. And you see these green islands around every telephone pole that the farmer moved back a little bit because he didn't want to hang his boom up on the telephone pole, so he didn't get the glyphosate. Well, everything got the glyphosate died 2 or 3 weeks early at a prime time when it should be filling beans and growing beans. And so the whole yields dropped. For a half mile, you can look down and see every one of his telephone poles where he had a little green island around it, still working for him. It's the way it was created. With the glyphosate, we terminated that early. Same thing with take-all, root and crown rot on wheat. The only difference in this picture between the left side here, where that little red flag is, and the right side, where you had very little take-all versus extremely severe take-all, was one application of glyphosate the previous year on soybeans, on the Roundup Ready soybeans. So you see that increase in disease. One that's becoming a real serious for us is head scab because of the toxins that are produced. The zearalenone, the other mycotoxins, T2 and T1 toxins, whole series. Miriam Fernandez has shown that if you apply glyphosate one time in the previous 3 years, you change the soil biology and you'll have a significant increase in head scab and fusarium root rot. If you do it every year, it'll be about as a burn down, you'll have about a 300% increase then in severity of this disease. Andreas Tiedemann reported at the National Fusarium Head Blight Conference that you can't even use the bedding now because the toxins are produced from root infection, not just from head infection and grain infection. So that if you bed your cattle on the straw, you can have high enough levels of your zearalenone estrogenic toxin to render those animals sterile so that they're infertile. You disrupt the endocrine hormone system with the mycotoxin and it has some very serious consequences. We have the resistant weeds, so we've essentially lost a lot of the benefit of the whole process to start with, except we've added now a very serious toxin in our food chain. So there are food and feed safety concerns that we know of. We have reduced nutrient density, but all the other problems here, and I can point out some of those if you look at the Roundup Ready versus the non-Roundup parent, and you see the reduction in critical nutrients there. Half of the sulfur that you need. If you don't have sulfur, you're not going to have any enzymes produced because it's your sulfur amino acids, cysteine and methionine, that are responsible, or that your proteins build on. Look at your manganese, look at your iron. Same thing in soybeans. Well, we're growing alfalfa, especially as a very critical feed for our dairy. You see what happens then with manganese deficiency from cattle production or pig pseudo pregnancies and all of the other problems, the miscarriage, the deformed cattle. You have to have manganese in order to move calcium into the bones. You look at the science that shows levels that will affect different toxicity to different tissues and different systems there, and you see what these levels are from a scientific standpoint, from a safety standpoint, the precautionary principle. We should say that it would be at least 100-fold lower than this to honor the precautionary principle that we used to use before the glyphosate and Roundup Ready. This is the level that the EPA says is perfectly safe. Now you see in water in the U.S., they say 0.7 parts per million is perfectly safe. 0.1 part per billion will shut down your defense mechanism, your own immune system, and the GI tract. 0.1 part per trillion will disrupt the endocrine hormone system. And yet you look at the levels that you see here, 0.7 in drinking water in Australia, it's 1 part per million. So we're a little lower than you are even in that safety factor, but that's way over what you saw over here in this level, or we know to have documented in the scientific area. And so we see children born every 20 minutes with cleft palate. You see the effect in the environment, on the other animals from that endocrine hormone disruption. You have the tragedy at Yakima, Washington, where they started dumping glyphosate in the drinking or in the rivers for invasive weed control. Still, the levels are well below that 0.7 parts per million, but they started in 2008. Within 2 years, we had a massive epidemic of stillbirths and anencephaly, where the baby's brain doesn't develop. You get to hold your baby for 24 hours or 48 hours at a maximum before it dies, if it's even born alive. And you see the personal tragedies that are involved there, because it's a very strong antibiotic, again, against the beneficial organisms in the GI tract that protect us from all of the pathogens, stimulates the pathogens. And so you see the chronic botulism in our animals, from the 1/10 of a part per million glyphosate in the feed will suppress your beneficials that suppress that Clostridium botulinum and the other species that produce the neurotoxins. So we have dairies that have gone out of business. We average about 6 dead cows a month from chronic botulism that most veterinarians can't figure out what it is. We're very familiar with the acute botulism, but not the chronic that you see in this situation, where the toxin's produced within the animal rather than produced in a rat or a raccoon or something that's been wrapped up in a hay bale and produced the toxin there. You have the study with Judy Carman, from an Australian veterinary toxicologist, on this Iowa study on pigs, 5-month study, showing the impact of the GMO feeds and the glyphosate then on the stomach. The pig's an excellent animal to work with for the toxicology. This is what your stomach, or my stomach, should look like. That's a healthy stomach, non-GMO, non-glyphosate. You see the irritation, you see the ulceration, those little black spots, and they're actually ulcers in the cell wall. And a ruminant animal, sheep and cattle, it can be 3 and 4 inch lesion there that leaks everything out into the peritoneal cavity. Food's not digested properly in that. You see a different gut microbiome when you have inflammatory bowel diseases, or when you have, this happens to be gout here. Different organisms, so they're not able to digest and metabolize a lot of those products of our own metabolism when you have glyphosate present. You see all of the inflammatory bowel diseases that, from that gut dysbiosis that glyphosate in our food induces by taking out the beneficial organisms there. You see the new diseases in our animals as a result of that disruption of the balance in the gut microbiome. I have a neighbor that just had duodenal hemorrhagic syndrome. He had to have 12 inches of his intestine taken out. Very heavy, or relatively heavy, glyphosate user around his home. I've lost 3 neighbors to glyphosate related, one of them to cancer, non-Hodgkin's lymphoma, one of them to Alzheimer's, another one to end-stage kidney failure. I have 2 other neighbors that are in late-stage condition in there, but we see also the impact then on the environment. With bees, the only thing that really accounts for the total losses in the bees from a colony collapse is where you have, they're all under mineral nutrition deficiency. They have essentially no lactobacillus or bifidobacteria in the honey crop to digest the honey. There's plenty of honey in the hive, plenty of bee bread, but they can't digest it because of the glyphosate has taken out the organisms that are very sensitive to glyphosate that are required there. And then you have the endocrine hormone disruption. You tie that together with the neonics, another very strong endocrine hormone disrupting chemical, and you have a recipe for failure. This is from Amos's research, again just showing in a normal honey crop, you have that viscous stomach area essentially where it's digesting the honey and the bee bread and using it and keeping that tissue all healthy. With the GMO crop and the glyphosate exposure there and the A and the C up there, you see that it can't digest it. Those food materials just become a bunch of gravel from a physiologic standpoint, and the bee is starving to death and the tissue finally dies. You see it in the environment in a lot of other ways. And then Lake Erie and the U.S., the University of Wisconsin reported in trying to find out where all their phosphorus is coming from that 1/3 of a pound of glyphosate is now going into Lake Erie every year from every acre in the watershed because of the heavy use of glyphosate. We've already chelated with all of the minerals that the soil can no longer hang on to any of that glyphosate, so that this water-soluble compounds going right into the rivers. You get then the algal blooms because many of the algae have resistance or tolerance to the glyphosate. Cattlemen's Association gave testimony before Congress in 2002. 2 conditions, one of them premature aging of the animals, the other one was infertility, pregnancy loss, miscarriage. We know then, this is some data that several veterinarians in surveying North America presented, and you can see they were concerned about 20% of their lost pregnancies, but you look at a lot of the data, and that's those that were pregnant and those that are now open, and you see it's closer to a 50% in many of those herds. Had a dairy about 60 miles from where I live that had 70% lost pregnancies, went into bankruptcy. You see that loss in fertility. In the Western world, the fertility levels have dropped 30% in the last 5 years in the U.S. and also in Europe. And so you see in the percentage of functional sperm and how it's dropped. You also see the effect on the egg, so that even in the in vitro fertilization, they're having difficulty even finding an egg that's in good enough condition to even try in vitro fertilization on. And so Newsweek had a big article on who's killing America's sperm. It's not just America. This is a worldwide condition where they're using glyphosate as an herbicide. We just had the cancer trial in California. The judge wouldn't let them present this data. This was Monsanto's own study in 1981. They showed that 23.8% of the animals that received the low doses of glyphosate developed, this was Sprague Dawley rats, an international standard, but 23.8% developed malignant lymphomas, 0 in the control. This data, when Monsanto objected to having it presented, even though they had to release it in the discovery process, when they objected, the judge accepted their objection. This isn't data that was used in the settlement. They only used about 5% of the actual hard data that they have showing that glyphosate is a very serious carcinogen. You have the independent study of Fertility at Caen, France. Again, showing that at 4 months, the rats started growing mammary tumors, liver tumors, kidney tumors, pancreatic tumors. You also had then the other effects, damage to the liver and to the kidney, that also accompany that glyphosate, an independent study. But again, not permitted by the judge when Monsanto objected. But you have also the senior toxicologist at EPA on her deathbed before she passed away from cancer, wrote a letter to her supervisor telling him that she hoped that in the future he would quit changing the toxicology reports to show that it's not a carcinogen, that it's not a problem. She outlines the 16 known mechanisms for cancer induction and says glyphosate triggers every one of them. It's not just one or two. Every known mechanism that triggers cancer is stimulated by glyphosate. You also have a lot of other factors, a lot of other damage. This is from part of those 28 case studies that Ted Dukemeyer, veterinary toxicologist in Saskatchewan, reported at the veterinary symposium, the effects of glyphosate in the feed. He has all the data on the levels of glyphosate. They're down to less than a part per million. You see what EPA permits, and that is several hundred times or 1,000 times above it. But you see this liver. I have a neighbor, again, that has non-alcoholic fatty liver disease. They say we can't figure out where it came from. All you have to do is look for the source is glyphosate. You'll see those problems. You see the other problem here with celiac disease. This is in Alberta, Canada. Children requiring hospitalization. Rochelle, you're getting nervous and you're going to wear that chair out. Can I have just a couple minutes more? I haven't had any rotten tomatoes or potatoes thrown at me yet. Maybe they're coming here in force. But I want to share with you because that same epidemiological curve that you see here with the children fits now all 32 of these diseases. The only epidemiological factor that we can find that fits all of these diseases is from the CDC data and the USDA data is the exposure to glyphosate on the GMO crops. And it fits every one of them. You can look at the curve, you can look at the actual data, and quite often, as you see here with the Alzheimer's, you see two curves. You see the rate in increase of Alzheimer's. Down here, that first real jump, 1974 or 75 when it started, just from the glyphosate alone. And then when we had the GMO crops, 1996, we increased the rate of glyphosate 5 to 15-fold. We could dump it on the crop right now. You became a heretic if you had a weed in your field. And so it was dumped on, and you see the consequence. Public Health Service sent out a notice to all of our public health agencies and said, in the next 20 years, plan on a 20% increase in Alzheimer's. Then they had a little note at the bottom. They asterisked it, put a note on the bottom and said, not in your 70 and 80-year-olds, but in your 40 and 50-year-olds. That's where we're seeing all of this. And then you look at our children and the effects there. I mentioned I do a lot of consulting in Central America. The end-stage kidney failure, 1 in 4. And El Salvador is predicted to die from end-stage kidney failure from glyphosate exposure and sugarcane. Well, the glyphosate goes out a month before or 5 weeks before they're in there harvesting. They burn the stalks or burn the leaves to get rid of all of that trash. Where's the glyphosate coming from? It's stored in the stalk, and you'll see them take that machete and cut off a little chunk of sugar cane, and they put it in their mouth and chew it. That's where your glyphosate's accumulated. But you see the these are young people that are dying. These aren't old men that have had a full life and made a contribution to society or had a chance. These are people still in that young families trying to get established that were eliminated. You see the autism epidemic in the U.S. in 2007, it was 1 in 150 kids that were diagnosed with autism. 2 years later, it was down to 1 in 100. A few years after that, it was down to 1 in 50. It's 1 in 38 now. And it's predicted that by 2025, or some say 2032, it'll be 1 in 2. There isn't any society that can physically provide the support that's required just for this one disease, leave alone all of the others. And then when you look back and see before glyphosate, it was 1 in 10,000. A tragedy of incalculable damage to society. We have the flawed safety evaluations and the corruption and collusion that's been involved in this whole process that's come out in the Monsanto papers that also weren't permitted to be submitted to the jury in this last case, but probably will in the case that's coming up here in the first part of November. Will be a class action lawsuit on the non-Hodgkin's lymphoma again. And you say, well, yeah, they should be substantially equivalent because they've looked at the test rations and they're feeding the control group the same thing that they're trying to test for. Should be substantially equivalent, but it's fraudulent science. They've falsified the whole thing. It's scientifically irresponsible, what we've seen, and that's why in Steve Drucker's book, Altered Genes, Twisted Truth, he's documented that corruption of science and political corruption and fraud that is all involved in the GMO program. I'd recommend that book to you. You can get it on Amazon. Another book that I would recommend is Michelle Perrow's, Dr. Michelle Perrow's, a pediatrician, What's Making Our Children Sick? She connects the dots between the GMO foods and the Roundup, the glyphosate, and the environment, and the tragedy that we see in our children. When you find yourself in a hole, stop digging. That used to be the old saying that we went by. Now we say, well, it's not working for the resistant weeds, so we have to add more. We just keep digging more, or adding more material, digging deeper, or we start adding dicamba or 2,4-D or both of them, then to the Roundup Ready to add additional endocrine hormone disrupting and remediation, or for turning it around. You need to recognize the problem. You need labeling for that. We don't have any labeling. We don't know how much glyphosate's in the food. USDA refuses to release their data. Tony Mitra has a book out, an e-book, $9.95 on Amazon, on poison foods of North America, where he's taken 250,000 of the Canadian Food Inspection Authority's data and analyses, so that he's organized that, and you can go and see how much glyphosate's in all of these food products on it. We can correct it. If we're willing to do that, prevention is by far the best. There are some things that will remove glyphosate from the body, from most of the organisms, or organs and blood and urine. That would be the humic acid, zeolite, clinoptilolite. There are some biococktails that will do this from soil, and some rather exciting things in just the last couple of years with raw sauerkraut juice and raw apple cider vinegar and May well be the same thing with the vermiculture materials, any of those materials that have acetobacter in them. Acetobacter is reported to break down glyphosate to its complete degradation component. So that right now, for 16 of those 32 diseases that I showed you that curve on, the best cure that we know of is a fecal transplant. You say, well, it doesn't sound very good to me. I can tell you, if you have Clostridium difficile diarrhea and you're over 65, you have a 95% chance of not surviving that within 1 month without a fecal transplant. Because the Clostridia now in most areas are resistant to all of the antibiotics. You'll see the same thing for autism, for others, that it's about a 95% cure if they change their diet. If they don't, you wipe out that new gut microbiome that you established with that fecal transplant, and you're right back to starting point again. There are some probiotics. We rarely have any success from an oral route. Swedish have patented a capsule that they claim will get it into the intestine, the small intestine, the colon. But these are organisms. I mentioned the acetobacters and the Saccharomyces are the only two that will take it all the way down on their own. The others will take it part way, and then you start combining them. There's some good books out. Mentioned 2 of them. There are some others. Pass that one around. If you can get as a free book that will have a lot of data in it for you. I'd summarize then that future historians may well look back and write about our time, not about how many pounds of pesticides we did or did not apply, but about how willing we are to sacrifice our children. Jeopardize future generations with this massive experiment that we call genetic engineering that permits us to dump such toxic products as glyphosate on our food based on false promises and flawed science just to benefit the bottom line of a commercial enterprise. Appreciate the opportunity to be with you and apologize for not getting my act in here a little faster here rather than making you sit quite so long. Many thanks for this opportunity.